Rockets have come a long way since the first ones that put men on the moon. Your smartphone has more computing power than the systems built into the rockets that led Neil Armstrong to that historic moment. In the last 60 years, it is estimated that 35,000 rockets have been sent to space. While most launch attempts are done without any issues, there are occasions where this isn't the case. A single error can cause years of work and potentially billions of dollars to be destroyed in seconds. Number 5. Antares Rocket. On October 28, 2014, NASA had scheduled the launch of an unmanned Antares rocket carrying a Cygnus cargo spacecraft on the Orb-3 resupply mission. It was set to launch from the Mid-Atlantic Regional Spaceport at Wallops Flight Facility, Virginia. The goal was to resupply the International Space Station, something that had become fairly routine. Unfortunately, things didn't quite go to plan that day. As the launch began, it was quickly obvious that something wasn't quite right. The range safety officer sent the destruct command just before impact. Orbital Sciences formed an anomaly investigation board to investigate the cause of the rocket failure. They traced it to a failure of the first stage LOX turbopump, but could not find a specific cause. However, the refurbished NK-33 engines, originally manufactured over 40 years earlier and stored for decades, were suspected as having leaks, corrosion, or manufacturing defects that had not been detected. No one was harmed during the launch, but the launch pad had sustained significant damage. On October 6, 2015, almost 1 year after the accident, Pad 0A was restored to use. Total repair costs were about $15 million. Number 4. Proton-M Rocket. In July 2013, a Proton-M/DM-03 carrying 3 GLONASS satellites failed shortly after liftoff. The unmanned vessel began pitching left and right along the vertical axis within a few seconds of launch. Attempts by the onboard guidance computer to correct the flight trajectory failed and ended up putting it into an unrecoverable pitchover. The preliminary report of the investigation into the July 2013 failure indicated that 3 of the first-stage angular velocity sensors, responsible for yaw control, were installed in an incorrect orientation. As the error affected the redundant sensors as well as the primary ones, the rocket was left with no yaw control, which resulted in the failure. As a result of the July 2013 Proton-M launch failure, a major reorganization of the Russian space industry was undertaken. The United Rocket and Space Corporation was formed as a joint stock corporation by the government in August 2013 to consolidate the Russian space sector. Deputy Prime Minister Dmitry Rogozin said, "The failure-prone space sector is so troubled that it needs state supervision to overcome its problems." 3 days following the failure, the Russian government had announced that extremely harsh measures would be taken to fix its space program. Number 3. GPS IIR-1 Rocket. On 17 January 1997, the GPS IIR-1 rocket was set for launch from the launch complex at the Cape Canaveral Air Force Station. It was to be the first Block IIR GPS satellite to be launched and was to have been operated as part of the United States Air Force Global Positioning System. But just 13 seconds after launch, the rocket failed incredibly. An investigation determined that the failure was caused by a crack in the casing of the No. 2 GEM 40 solid rocket motor, which started to form at T plus 6 seconds and grew from there. At T plus 12 seconds, the solid rocket booster, or SRB, casing ruptured and debris struck the No. 8 SRB next to it, causing that motor to fail as well. 1 second later, the range safety destruct charges automatically activated, causing the rocket to auto-terminate, which led to the self-destruction of the first stage and the detonation of the remaining SRBs. The range safety officer sent a manual destruct command to terminate the upper stages for safety purposes. Debris from the explosion fell into the Atlantic Ocean and on the Cape Canaveral Air Force Station. Some debris landed around the launch pad and a small fire started. Other debris landed in the parking lot outside the complex blockhouse, destroying 20 cars and trucks that were located there. 250 tons of debris fell within 915 meters, or 3,002 feet, of the launch pad. Personnel of the area around the launch site were advised to stay indoors, close windows, and turn off air conditioning systems as a precaution, as some vapors from the fuel could be irritant or toxic. The explosion was reported to have been felt 40 kilometers or 25 miles away from the launch site, and damage to store windows 16 kilometers or 9.9 miles away was reported. Number 2. Vanguard TV-3 Rocket. The Vanguard TV-3, also called Vanguard Test Vehicle 3, was the first attempt of the United States to launch a satellite into orbit around the Earth. After the successful Soviet launches of Sputnik 1 and Sputnik 2, the USA was keen to get some success of its own. The TV-3 was a small satellite designed to test the launch capabilities of the three-stage Vanguard and study the effects of the environment on a satellite and its systems in Earth orbit. It was also to be used to obtain geodetic measurements through orbit analysis. The launch was set for takeoff on December 6, 1957. At launch on 6 December 1957 at 4:44 p.m. at the Atlantic Missile Range in Cape Canaveral, Florida, the booster ignited and began to rise, but about 2 seconds after liftoff, after rising about a meter, the rocket lost thrust and began to settle back down to the launch pad. As it settled against the launch pad, the fuel tanks ruptured and exploded, destroying the rocket and severely damaging the launch pad. The exact cause of the accident was not determined with certainty due to limited telemetry instrumentation at this early phase, but Martin Marietta concluded that low fuel tank pressure during the start procedure allowed some of the burning fuel in the combustion chamber to leak into the fuel system through the injector head before full propellant pressure was obtained from the turbopump. The Vanguard satellite was thrown clear and landed on the ground a short distance away, with its transmitters still sending out a beacon signal. The satellite was damaged, however, and could not be reused. It is now on display at the Smithsonian Air and Space Museum. Number 1. IntelSat 708 Rocket. On February 15, 1996, the IntelSat 708 was set for takeoff at the Jichang Satellite Launch Center in China. The Long March 3B launch vehicle failed during launch, veering off course immediately after liftoff. After traveling sideways instead of going upwards, the rocket broke up and exploded 1 minute after takeoff. The rocket ended up crashing into nearby Mailin village, killing 6 people and injuring 57, according to a Chinese report. American estimates suggest that anywhere between 200 and 500 people might have been killed in the crash. A team went to the village to document the damage and observed buildings that were completely destroyed. The nature and extent of the damage remain a subject of dispute. After the launch failure, the Chinese investigation found that the inertial measurement unit had failed. As a result of the investigation, the Long March rocket family improved in reliability and did not experience another mission failure until August 2011. This wasn't the end of this story, however. The participation of American companies Space Systems Loral in the IntelSat 708 and APSTAR 2 investigations caused great political controversy in the United States. A U.S. government investigation found that the information in the report detailing how the rocket failed, which was carried out by an independent review committee, had been illegally transferred to China. Satellite technology was subsequently reclassified as a munition and placed under ITAR restrictions, blocking its export to China. In 2002, Space Systems Loral paid $20 million to settle charges of violating export controls. We all enjoy the luxuries of using our GPS on our smartphones or having navigation available in our cars. To continue to enjoy these, rocket launches are essential in order to maintain these devices and to deliver new technology. All rocket manufacturers can do is learn from their mistakes and try to prevent any future disasters. Thanks for watching. Don't forget to like the video. If you learned something today, consider subscribing. It's free.